Solve the system using the elimination method. If the system is inconsistent or has dependent equations, say so. The first step in solving using the elimination method is to get the equations in the right form. So we have to put them in standard form. So that means ax plus by is equal to c. So the variables on one side, the constant on the other side. So the first equation is already written for us in standard form. So negative 3x plus y is equal to 6. The second equation, we need to move the 6x to the other side. So I'm going to subtract 6x from both sides. And we get negative 6x plus 2y is equal to 12. So now we have negative 6x plus 2y is equal to 12. With the elimination method, we need to look at the coefficients. So we need to look at either at these two numbers or we need to look at these two numbers. They're understood one there. And we need them to be opposite of each other. So we can, when we add them, we can eliminate that. So I'm going to choose to multiply the top equation by a negative 2. Because when I multiply negative 2 times a negative 3, that's going to give me a positive 6. And 6 minus 6 is going to give me that 6x. So I'm going to multiply the top equation by negative 2. So I get 6x minus 2y is equal to negative 12. And then my bottom equation is negative 6x plus 2y is equal to positive 12. So when we add these equations, you can see that that's eliminated because 6 minus 6 is 0. That's eliminated because negative 2 plus 2 is 0. And that's eliminated because negative 12 plus 12 is equal to 0. So we end up with 0 is equal to 0, which is a true statement. So if you have a true statement, that means that the equations are dependent equations. Okay, so a true statement means that the equations are dependent equations. So the solution set, when we write it in set interval notation, would be for all xy, so for all xy such that, and then we're going to pick one of the equations. And normally we pick the equation that doesn't have a common factor. So if we look at 2y, 12, and 6, they have a common factor of 2. So that's why we wouldn't use this equation. If we look at negative 3, 1, and 6, they don't have a common factor, so we're going to select that equation. So negative 3x plus y is equal to 6. So the solution is for all xy such that negative 3x plus y is equal to 6. So this is saying that no matter what xy value we put, it's going to be a solution for both equations because they end up being the same equation. So these are dependent equations. So that's our solution for the system of linear equations.